Today we're beginning our unit on polars. Some of this is going to feel very new and exciting and interesting, and some of it will feel very comfortable and familiar to you. We rely heavily on trig for polars. So let me introduce the polar coordinate system to you today. So far, we have been using the Cartesian coordinate system, x, y. Every point is x and y. X is in the horizontal direction, y is in the vertical direction, and you've been graphing, plotting points, doing lots and lots of things with the Cartesian coordinate system. We can graph these points really quickly. The point 2, 3 would be to the right 2 and up 3. That would be point A. The point -3, -2 would be to the left 3 and down 2. That would be point B. 4, -1 would be right 4, down -1. And -4, 5 would be to the left 4 and up 5. Left 4, up 5. That would be point D. So very familiar with you, to you. We can graph equations, we do lots and lots of things in the Cartesian coordinate system. Now let's take a look at the polar coordinate system. No more x's and y's. Instead, r's and thetas. So this should look familiar to you because of our study on trig. So a point is no longer going to be in the polar coordinate system. We don't call it x, y. Instead, we call it r theta. R has to do with the distance from the origin. Theta is theta. This is exactly what we used in trig. So this is theta is equal to 0 or 2 pi. Here's theta is equal to pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, pi over 2, etc. So theta is going to go around and around and around. R has to do with the distance from the origin. Okay, the origin is also called the pole in the polar system. We will still refer to it as origin as well. So let's plot these points. So remember that this is r and this is theta. So when theta is 0, we're on the positive x-axis, what we think of as the positive x-axis. R is equal to 9 means we go out 9 units. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. There is the point. There's point A right there. Okay? 6 pi over 3. 6 is r, pi over 3 is theta. I like to go to theta first. It's funny because when we were plotting x's and y's, I would always go right or left first and then up or down. But I could have gone up and down first and then right or left. With polars, my preference is to always go to theta first and then apply r. So I'm going to go to pi over 3. Here's pi over 3. Okay. So we're going around to pi over 3, and then I'm going to go out 6 units. So 1, 2, 3, 4, 5, 6. That would be the point B. Okay, C is the point 4, 5 pi over 6. So I go to 5 pi over 6, and then I go out 4 units. So 1, 2, 3, 4. Here's point C. 8, 5 pi over 4. 5 pi over 4 is right here. We go out 8 units. I know on this grid all the way to the end is 9, so 8 will be 1 short of 9 right there. So this is point D. 5, 3 pi over 2, so we go to 3 pi over 2, and then out 5 units, 1, 2, 3, 4, 5. There is point E. And lastly, 11 pi over 6, we go around to 11 pi over 6, and then out 3 units, 1, 2, 3. There's point F. Okay, what would happen if theta was negative? Well, we would do exactly what we have been doing so far with our study of trigonometry. So this point, 6 negative pi over 3, I'm going to go to negative pi over 3. Negative pi over 3 goes backwards or clockwise pi over 3 units. So I'm here. I'm right here. Negative pi over 3, remember, is called coterminal with 5 pi over 3. And then out 6 units, so 1, 2, 3, 4, 5, 6. There's point G. Negative 5 pi over 6. Negative 5 pi over 6 is not all the way to 5 pi. It's not all the way to negative pi, right? It stops a pi over 6 short. And then we go out 4 units, so 1, 2, 3, 4. There's point H. Okay, negative 5 pi over 4. That is past negative pi. So it's 1 pi over 4 past negative pi. And then we're going to go out 8 units. Here we are at point J. Okay, 5 negative pi, out 5 units, 1, 2, 3, 4, 5. There's point K. Negative 5 pi over 3. Negative 5 pi over 3 is almost all the way around, but we stop 1 pi over 3 short. It is coterminal with pi over 3. We go 3 units out, 1, 2, 3. There's point L. Lastly, negative 3 pi over 2. Negative 3 pi over 2, what would it mean for the radius to be 0? Well, if the radius is 0, we don't go out at all. So there is point M right there. Alrighty? Just like theta can be negative, R can be negative too. What do you think would happen if R was negative? If R is negative, we go to the angle, but then we're going to go negative R, so we're going to cross over the origin and go out that amount on the other side of the origin, on the other side of the pole. So pi over 3, I'm going to go to pi over 3. Here's pi over 3. But since R is negative, we're going to cross through the pole and come over here to 4 pi over 3. So I'm going to go out 6 units on 4 pi over 3. 1, 2, 3, 4, 5, 6. There we are at point N. 5 pi over 6, go to 5 pi over 6. Negative 4 is through the pole. 1, 2, 3, 4 units. There's point P. 5 pi over 4, 5 pi over 4, negative 8, 5 pi over 4, negative 8 would be way out over here. There's point Q. 3 pi over 2, 3 pi over 2, negative 5, 1, 2, 3, 4, 5. There's point R. Okay? 11 pi over 6. Go all the way around to 11 pi over 6. And then we're going to go negative 3. Negative 3 would be on the other side of the pole. 1, 2, 3 units out. There's point S. Okay. Negative pi over 12. Negative pi over 12. Negative 7. Through the pole, 1, 2, 3, 4, 5, 6, 7 units out. There's point T. Negative pi, negative 9. Negative pi, negative 9. Way out over here. There's point U. Okay, 3 pi. What would 3 pi do? Well, all the way around is 2 pi. 1 more pi is coterminal with pi. Negative 9 is at the same point that U was on. So we'll put V up there too. So that's how we plot points in polars. Plot points. So plotting points in polars is a little bit more involved than plotting points on the XY plane. So you can imagine what it's like to plot equations. We're going to be doing that. All right, so since theta can be positive or negative, and theta can also be more than 2 pi or less than negative 2 pi, r can be positive and r can be positive or negative, we can name the same polar point in many, many ways. Many different polar coordinates name the same point. So let's name this point in a different way. Well, all right, let's go use our graph up here to help us. Pi over 3, 3 is that point right here. Let me get a different color. It's this point right here, right? Well, how else can we name that? And in class, I will take several people's suggestions. One way to name it is to go with a negative theta. If I go negative theta, it would be negative 5 pi over 3, 5 pi over 3. That's one way to name it. Another way would be to come over here, go past pi over 3 and go around to 4 pi over 3. 4 pi over 3, negative 3. 4 pi over 3, negative 3. Just remember to put the r first. Okay? And then we could also do a negative, go negative to get to this angle, negative 2 pi over 3, and out with it to a negative 3. So negative 3, negative 2 pi over 3. Those would all be ways. And there are many, many more ways also, because we can keep adding 2 pi to this and it names the same angle. We can keep adding 2 pi to this and it names the same angle. All of these. Okay, we can subtract 2 pi, names the same angle. Or, I keep saying angle, names the same point. Alrighty. So which of the following is not the same as 4 2 pi over 3? Well, 4 2 pi over 3. 2 pi over 3 is over here, and we're going out 4. So we're looking which of the following is not this point. So 5 pi over 3, 5 pi over 3, negative 4, that would name the same point. Negative 4 pi over 3, out 4, that also names the same point. 4 pi over 3 would be down here. And if negative 4 would take it over here, there is no way a 4 pi over 3 would name that point. So this one is our answer. If we go over here, 8 pi over 3. That is 2 pi over 3 and another, that is 2 pi and another 2 pi over 3. So that names the same point as well. So the correct answer here would be C. That does not name the same point. All right. If we lay the Cartesian coordinate system on top of the polar coordinate system, we can write the same point in either rectangular form or polar form. So this is the point xy, but it also could be named by r theta. We'd like a way to convert from polar to rectangular and rectangular to polar. So we're going to use trig to do that. Think back to SOHCAHTOA. Okay. Sine of theta. Sine of theta is opposite over hypotenuse, y over r, and that means if I solve this for y, I'm multiplying both sides by the r, y is r sine theta. Cosine of theta. Cosine of theta is adjacent over hypotenuse, x over r, which means that x is r cosine theta. Using these, if we're given a point in polar form, we can get the x and the y coordinate. Now we need a way, if we're given the point in rectangular form, how to get the r and the theta. Well, the Pythagorean theorem holds, so r squared must be x squared plus y squared. Also, if we go to tangent, tangent of theta is opposite over adjacent y over x. So if we're given x and y, we can get r and we can get theta. So these right here are super important for us to know. They allow us to convert from one form to the other. Okay, I listed both of those, all of those in this box. Let's do some conversions. So here they tell us that we are given polar coordinates and we're supposed to write them in rectangular form, XY form. Rectangular form, think to yourself, XY. We want X, we want Y. Okay, so here we are. It's in polar form, we want XY form, so X is equal to r cosine theta, Y is equal to r sine theta. X is 3 cosine of pi over 4. Cosine of pi over 4 is square root 2 over 2. So x is 3 square root 2 over 2. Y is r sine theta. R is 3. Sine of pi over 4 is square root 2 over 2. So y is also 3 square root 2 over 2. So the point is 3 square root 2 over 2, 3 square root 2 over 2. And it makes sense because we have a pi over 4 angle that the x's and the y's are going to be the same. Okay, let's do this one. So x is r cosine theta, y is r sine theta. So r is 6. Cosine of theta. Cosine of theta is the pi over 3 angle in quadrant 4 where cosine is positive. This will be 1/2. So x is 3. Y is r sine theta, so 6 sine of 5 pi over 3. Sine of 5 pi over 3 is a negative because it is in the 4th quadrant, and it's a square root 3 over 2 because it's a pi over 3 reference angle. So y is negative 3 square root 3. So the point is 3, negative 3 square root 3 in Cartesian form, rectangular form. Okay, a couple more of these. Alrighty. X is r cosine theta, y is r sine theta. If you write this every time, you guys, you won't have to worry about memorizing it. You will know it. R is negative 4 cosine of theta. Again, we're in quadrant 4. Cosine is positive. Pi over 6 reference angle, square root 3 over 2. So x is negative 2 square root 3 when we reduce that. Y is negative 4 sine of 11 pi over 6. That is negative 1/2. So y is 2. So this is negative 2 square root 3, 2. Let's affirm something here, you guys. What quadrant is this point in? What quadrant is that point in? 11 pi over 6 is over here, right? But this negative 4 takes it to the other side. This point is in quadrant 2. Is this point in quadrant 2? X is negative, y is positive. Yes, it is. Okay, a quick check. Could have done that for those two as well. Okay, one more like this. 7, 3 pi over 2. When I notice that I have an axis, I am not going to go through this process if I know that I'm on an axis. 3 pi over 2. 3 pi over 2, out 7. Out 7. I do not need to go through that process to name that point in xy form. I hope you don't either. That is the point 0, -7. Okay, so make this make sense. It all makes sense. So don't do work that you don't have to do. All right? We're going to take that knowledge with us when we go to this next little section. Right, now we're going to go backwards. We're going from rectangular form to polar form. Now, since we can write polars in many, many ways, and we know lots about trig values and stuff, we need to be careful doing this. First thing you're going to do is determine what quadrant you're in. What quadrant are we in, you guys? X is negative, Y is positive. We're up here in quadrant 2, right? So we need to make sure our polar form is in quadrant 2. Okay? All right. I know that r squared is x squared plus y squared. Always. So r is equal to the square root of x squared plus y squared. What is x squared? 1. What is y squared? 3. So r is the square root of 4, which is 2. Tangent of theta is y over x. It's the slope, right? Y over x. So tangent of theta for us is square root 3 over -1. That means tangent theta is negative square root 3. So what value of theta in quadrant 2 makes tangent negative square root 3? Well, it would be the pi over 3 angle in quadrant 2. So theta is 2 pi over 3. That is one way to write it. Or we could go negative 4 pi over 3, right? Lots of ways to write it. But our answer here would be 2 pi over 3. One answer here would be 2 pi over 3. Remember to put r first. Okay, what about this one? What quadrant are we in? X is positive, y is negative, so we're down here in quadrant 4. So we need to make sure our theta is in quadrant 4. Alrighty. R squared is x squared plus y squared. So r is the square root of x squared is 9. Y squared is 3. So r is the square root of 12. Clean that up a hair. That is 2 square root of 3. Tangent of theta is y over x. So tangent of theta is negative square root 3 over 3. Okay, in quadrant 4, what theta makes tangent negative square root 3 over 3? That would be 11 pi over 6, or negative pi over 6. Either one is fine. Okay, so 2 square root 3, 11 pi over 6 would be the polar, one way to write polar coordinates for that xy form, that xy point. Okay, what quadrant are we in this time? X is positive, y is positive, so we are in quadrant 1. R squared is x squared plus y squared, so r is the square root of 36 plus, what is 2 square root of 3 squared? That would be 4 times 3, or 12. So r is the square root of 48. There's a 16 in that. 48 is 16 times 3, so 4 square root of 3. Tangent of theta is y over x. So tangent of theta is 2 square root of 3 over 6. reduce that, clean it up. 2 goes into 6 3 times, so we have square root of 3 over 3. So theta is, in the first quadrant, theta is pi over 6. So this would be 4 square root 3 pi over 6. That is one way to name the point in polar form. Okay, what about this one? Negative x value, negative y value. But I noticed something about this. I go negative 4, I go over to the left 4, and I go down 4. Since these have the same absolute value, I am not going to go through this process to find theta. I know that I am dealing with the pi over 4 angle in quadrant 3, which is 5 pi over 4. I already know what theta is. We do, however, have to find r. So r squared is x squared plus y squared. R is the square root of 16 plus 16. That's the square root of 32. Of course, there's a 16 in there. That would be 4 square root of 2. So polar form, 4 square root of 2, 5 pi over 4. That's one way to write it. Okay? Alrighty. So there is your intro to polars and the polar coordinate system. We're going to have lots of fun graphing very fun and funky pictures, graphs of equations in this unit.